So in the video that we just did, we were going about the line x equals 4. Now let's go about the line x equals 6. So if we're going to move over the line that we're going around over to x equals 6, then let's put in another vertical line here at x equals 6. Now we're still taking that same region we were dealing with before, the region that is in here, and has a sample rectangle that's still there, but we're going to be rotating that rectangle not around x equals 4 anymore. That's still going to be our boundary for our region, but the vertical line that we're going to be going around is x equals 6. So what that means is when I take this rectangle around there, I've also got to take this end over here around, and what it's going to do is produce a hole in the middle. So this means I now have to do the washer method, and the hole in the middle, I can call that a radius of lowercase r, and the bigger radius, I can call that a radius of capital R. And I'm going to set up the formula pi times capital R squared minus lowercase r squared. So sometimes it's called outer radius and inner radius. And in this case, the rectangle still has a thickness of dy. And we're still going to be going from 0 at the bottom and 2 at the top. But now we got to figure out what the inner radius is and what the outer radius is. Now, the inner radius, that's actually pretty simple. The inner radius is just going to be the x coordinate that you see on the right, which is 6, minus the x coordinate that you see on the left, which is 4. So the inner radius is just 6 minus 4, which is 2. So we've already got that part down. And now we just have to figure out what the outer radius is. Now the outer radius is coming from that x coordinate of 6, but then we got to put a x coordinate for this point over here. I'm just going to call it x. So therefore you subtract those two and you get 6 minus x. And I'm going to wrap that in parentheses so that way I can square that. Then I'm still taking the integral, blah, blah, blah. Okay, so now I got an issue that this is a dy, so everything needs to be in terms of y. That's not in terms of y. So therefore I need to solve for x, and that would be y squared. So now it's going to be 6 minus, instead of x here, I'm going to put y squared, that whole thing squared, minus 2 squared, which is 4. And then there's a dy, integral from 0 to 2, and with the pi outside. Now I'm confident you know how to finish this up. The hard part about these problems is the setup, but this required the washer method because we ended up with this hole. Now you can identify that just by noticing that the closer end of your rectangle has got a gap between the axis that you're going over and your rectangle. Now that didn't happen when we were going over the line x equals 4 because the closer end of your rectangle was on that line. So that's where you can just use the dis method. But here we had to use the washer method. All right, take care. Bye-bye.